Hello again. This is Dr. Ariella coming to you to talk about the last chapter for this class, Chapter 9, Using Statistics to Answer Questions. No, we're not going to be doing them. This textbook just talks about what they are and the significance of these statistics. And so they talk about descriptive and inferential statistics, which is important to know the difference between the two. Descriptive, you're describing things. So that's like describing your population, their age, sex, ethnicity, class, things like that, economic status. Inferential statistics are the actual, calculation of P's and ANOVAs and different kinds of, and correlation coefficients, so different kinds of statistical methods to find out whether or not you can infer a significant effect based on your results. So they talk about different aspects of descriptive statistics, measurement, and different aspects of that, and nominal, ordinal, and interval scale and ratio scale. So those are all important to understand which kind of scale you can use in not only describing things, but also which kind you can do certain statistical analyses with. So, for example, the authors mention on a ratio scale that this scale assumes a true 0 point. And so when you have things that have properties that can actually have a true 0, and they're saying that temperature does not have a true 0, because when you reach 0 in temperature, there's still a temperature. 0 is just a way to describe how warm or hot it is, like any number on the Fahrenheit scale or Celsius scale. But ratio scales have a true 0. So, for example, the light is on, the light is off. You've got a 0 and a 1 for off and on. And so, because of the true 0 point, the ratio scales allow you to make ratio comparisons such as twice as much or half as much. When psychologists evaluate changes in the DV, they try to use a scale of measurement that will provide the most important information. And so that's another reason to understand the difference between these different kinds of measurements and scales. Frequently they select the interval scale because they do not use measurements that have a true 0. So, for example, the Beck Depression Inventory is an interval scale, mostly because there's never, most people have at least a 1 or 2 on that certain scale. So ratio scales aren't done that often in psychology, but they could be done, say, in physics and chemistry and biology and things like that. And then measures of central tendency, just like it sounds. What are the tendencies of the data that you're looking at? The distribution. So the mode, it's the thing, the number usually that occurs the most often, but it could be participants. Your mode could be black, say, as in African American. So the mode, the median is the number or score that divides all the scores in the middle. So it's not the average of the scores, but it divides them in the middle. So it's the mid score, but not the average score. But it's the mid of all the scores that you have. And then the mean is the average. And they discuss, which ones should you use and why. And this is an important question because you don't want to use a measure of central tendency that's going to be misleading. And I think, when we're talking about statistics, and there's this quote that I've seen, you've probably seen, there's something like, it goes something like, there's lies and damn lies in statistics or something like that. And it's not because I think, generally speaking, that people try intentionally to lie about data. I mean, sometimes they do. Unfortunately, that has happened. But statistics is a gray area, you know, and it takes experience and research and you know, a lot of work to figure out when you use what for what. So that's one reason why when you enter in a doctoral program, the focus is on research for most doctoral programs, because that's it takes a long time to learn that. In most master's degrees, that's not usually the focus of that master program. Usually the focus is a practice kind of thing. But anyway, so you want to choose things, or when you're reading reports, you want to ask the question, did they choose the best measure of central tendency? Because if you don't, then the numbers can be misleading. And they have a good example in the textbook about that, so I won't really go over it. But you know, if you want to report that something is typical, then you want to be careful about what number you use to demonstrate that. And then they talk about graphing results and what kinds of graphs or charts you can use and why you might use them for certain situations. They mention on the bottom of page 177, think of how many words it would take to write about these results rather than present them in graph form. So I just want to say that yes, graphs and charts can say a lot and they can be very helpful. However, graphs and charts should never stand alone. If you include a graph or a chart, you want to discuss what the importance is of the graph or chart that you included. So it's very helpful to have them. I think you can see that from looking at the ones in your textbook or any other textbook or book, but you do want to discuss them if you're writing a report. So they discuss other kinds, and then calculating and computing statistics. So they talk about, authors discuss how you figure out different aspects of variability with the range and the variance, the standard deviation, and the normal distribution and why that's important. It's a really important mathematical finding, the normal distribution or the bell curve, and standard deviation and why that's important. They have a cartoon, it's great, on page 186, caution, hazardous data. It says, unlike the warning on this track, psychologists view data and statistical procedures as tools to help answer research questions, and I thought that was really good that they noted that. It's true, it is a tool, research is a tool, data is a tool, statistics is a tool. They're all tools, and some tools, as you might know, just take a longer time to figure out how they work than others. Like me and using circular saw for the first time in my life. Before I turned, right on my birthday, when I turned 48, I used a circular saw. Didn't kill myself. Anyway, correlation coefficients. So they're talking about the relationship, again, between two variables, not causation, but when do variables relate to each other and how much. The how much is important, obviously. If you say variables relate and the correlation coefficient is a 1, then not a 1, a 0.2, they don't really relate that well. So obviously the higher the number to 1 or minus 1, the stronger the correlation of those variables. And then they discuss different kinds of correlation coefficients like the Pearson product. So the textbook is just kind of, giving you a heads up about what these things are and what they mean, but we're not using them in this class. We're not trying to calculate statistical results. Inferential statistics, again, one of the purposes of inferential statistics is to decide whether or not you have a significant meaning powerful result. And so they discuss the nuances of statistically significant and where the 0.05 number comes from and where the 0.01 number comes from. So that's just a percentage, 0.05, 0.01, 5 in 100 or 1 in 100. So those have been decided. I mean, there's still debate about it, but those have been decided to a large degree, the 0.05 and 0.01, that those are statistically significant levels. So they discuss the null hypothesis, the t-test, degrees of freedom. Whoa, was that confusing to me? Yeah. So again, when you actually start computing statistics, then you'll get more into degrees of freedom and what that means and why it matters. Oh my gosh. And then the one-tail versus the two-tail test of significance. So this is where we, in earlier chapters and earlier videos, we discussed whether or not, if you state a hypothesis with a certain prediction, whether or not you can have a stronger result in your data. So again, the research question derives whether or not you'll have a directional or non-directional hypothesis. Yeah. So, but they also make a point that why don't experimenters always state the directional hypothesis? And the main reason is because they don't always know. Researchers don't always know how it will turn out, and they'd rather have some kind of helpful result than saying I didn't get the result that I wanted. So I think that's just kind of humanness. We want to get something out of all our time and effort. Although, again, to reinforce that a null hypothesis or disproving your hypothesis can also be important in research. Typically, our ultimate interest is not in the samples we have tested in an experiment, but in what these samples tell us about the population from which they were drawn. In short, we want to generalize or infer inferential statistics from our samples to the larger population. So, good point. And then they talk about type 1 and type 2 errors. So type 1, so they say, there always is a chance that your experiment represents one of those 5 times in 100 when the results did occur by chance. So, even though you may be able to say my results are statistically significant at the 0.05 level, you still have 5 chances. It's still low, but you still could, your data still could have been one of those very small occurrences when your data did come out that way because of chance, not because of the variable that you're testing. So that's when you get a type 1 error, and you say the hypothesis is true when it's not. Type 1 error, or alpha. And so that's one reason why some people like the 0.01 significance level, because you have fewer chances of having a type 1 error. Type 1 errors are sort of like a false positive. You say you had a positive result when you really didn't. The type 2 error is when you reject the hypothesis, but it's true. And so there's a good, a helpful table on bottom of page 199 about how these two things relate, the type 1, type 2 error, and the experimental hypothesis being true, and when the null hypothesis is true. And then they say, you should keep in mind that the typical practice is to set the alpha level at 0.05 because it places the probability of type 1 and type 2 errors at acceptable levels. So that's one reason why it's most common, the 0.05 statistical significance level is most commonly used. And then they talk about effect size. It's kind of odd, I didn't think they concluded this chapter very well, although maybe they think they're looking ahead. Concludes the chapter. But anyway, so you're gonna, if you haven't already, ideally you will take a statistics class, and I can tell you that statistics is hard for me. I'm not a whiz at it, but fortunately statistics is not algebra. And so in statistics, if you know how to multiply, add, subtract, divide, and use a calculator, then it's really a matter of wrapping your mind around what the different kinds of probability testing, statistical methods are, and what they mean, and when it's appropriate to use them and when it's not. And again, even if you never do a research study yourself, these make you much more educated, valuable, critical thinking consumers in the world. And there's unfortunately, a lot of misinformation or mythology or whatever put out, especially by the media. I see summaries of research quite a bit, and when I go back and look at a study, sometimes it just doesn't jive, or I don't draw the conclusions that the people did who wrote the article about it. So there is unfortunately a lot of bad research, and there are people who draw conclusions from research that aren't in the study itself. Not necessarily researchers. Sometimes that happens too, but sometimes other people looking at the information, the research report or study or whatever, or data, will draw conclusions that are inappropriate. So that's one reason why these kinds of classes are really important. I know they can be challenging and a struggle. They certainly were for me. But I'm much wiser in that respect. I'm not a genius by any means on statistics, but I can definitely have a much better idea when something was done well and when it wasn't, and help educate my friends and peers and things like that. And so it's cool. So hopefully you'll take it as an opportunity to be smarter about stuff and not just, oh my god, I got to do statistics, because it really is cool when you know stuff like that, and a lot of other people don't, and they don't understand it. So it's an invitation to put on your critical thinking cap and take on the challenge of learning this stuff, because it's great when you do know it. Alright, so thank you very much for your time and attention in the videos and your work in the class. I've appreciated and enjoyed your discussions, your assignments, and seeing how much you've learned from the beginning of the class to the end. So having taken this class, you definitely know a lot more than the general population does about research. So yay for you! All right, thank you, and aloha.